We start. Exponential equation, and suppose we have two kinds of exponential. One easy, like that. This is easy or nice, either way. And we use solving without logarithm. You try to express both sides using the common base, therefore x is 2. And the ugly, or complicated, or ugly, complicated case, 2 to the x equal 3 is impossible, and you apply logarithm on both sides. Don't forget the parenthesis when you apply logarithm. You apply the property number 7, no? And this x go to the front. And magically, the logarithm allows us to convert a exponential equation to linear equation. And finally, divide both sides by ln of 2. If you want to compute this, well, using the calculator, and you find the decimal approximation. This is two different kinds that you can see in the test, right? This is very, very ugly. This is super, super hard. Super hard. Well, not too hard, but it's super hard. You never see like that in the test. But when I finish this, I propose one extra credit. Okay, let me try this. Okay, in this case, I multiply whole thing, multiply by 4 to the x. What's the reason? The reason is because I want to remove this negative exponent. I don't like. So actually, if you want, you write like that, 4 to the x minus 10 over 4 to the x, because negative exponent is reciprocal, equal 3. But when you multiply everything by 4 to the x, then you multiply 4 to the x here, 4 to the x here, 4 to the x here. It's obvious we have 4 to the x squared, because it's this itself, no? Minus this and this is cancelled. It's just 10, and this is 3 times 4 to the x. Now you realize in that moment that we have one expression. Remember, in the test number 1, we study one equation that is called quadratic in front. Quadratic in form. This equation contains one expression. I don't care what expression. Square, like that. Minus 10 equal 3 times the same expression, pero no square. Entonces you call this, you call this u square. Actually, this is quadratic equation. You identify that, and you apply substitution, u equal 4 to the x power, and this is u squared minus 10 equal 3 times u. Wow, amazing. In this moment, you have quadratic equation. Pero quadratic equation non-standard, pero we express in standard right now. Is u squared minus 3u minus 10 equal to 0. And you solve this equation exactly the same we are doing throughout the semester. By factorization or quadratic formula, whatever you want. In this case, I don't want to do at the time because it's too easy. By factorization. The combination obviously is 5 and 2, because 5 times 2 is 10, and somehow 5 minus 2 is 3. Negative 5 and positive 2. Therefore, we have two solutions, no? U minus 5 equals 0. Therefore, u is 5. Another solution is u plus 2 equals 0. U is negative 2. U is equal to minus 2. Entonces you split the paper into parts, remember? And you copy for 5. U5. Remember who is u? U was the substitution, look. Remember, my goal is solve for x, not for u. And this is u values, intermediate partial answer. Then you copy 4 to the x equal 5. And 4 to the x equal minus 2. And just in that moment, we have the ugly, not super ugly, ugly equation, exponential equation que you solve using logarithm. Entonces you apply the standard logarithm que you have in your own calculator, no? suppose I apply, I don't know, LA. Why not? No discrimination with the LA. LA. And here exactly the same. LA or raised to the x power ln of negative 2. So now you apply the property 7 in both cases. Well, no, in this case, no. And you apply the x exponent go to the front. This is the idea for the property 7. And finally, you divide it by ln of 4 both sides, and you have this exact answer. But in this case, I don't need the exact answer. I need the decimal approximation. I put it in the calculator, and the answer is 1.1609. What's going on with this part? This part no solution. Why no? Because you know que logaritmo is impossible. Logaritmo of the negative number is totally undefined. This is one point of view. Another point of view is, look, this is exponential function. Yeah, I know that the graph of the exponential function look like that. I know also that the domain is all real number, but the range, no. The range is only 0 to infinity. The only positive values. Si es negative 2 is this line. Y equal negative 2. This line supposes y equal 4x. Never intersecting this curve and this line. This is the reason there's no solution. So in other words, in other easy and comprehensible word, the exponential never is negative. The answer. This is contradiction. This is contradiction. Contradiction, therefore no solution. Okay? Super. Okay. So this I never put in the final test like that. However, for extra credit, yes. Bueno. Take advantage. Extra credit. You turn into me the test day. No now. Don't try to fight to struggle to this now. No. Your problem now is the Alex. Finish the Alex, the last part. And prepare for the test number 4. I have in my hand the review package. But no, I don't want to complicate your life. This is a holiday, no? You disconnected the mathematical this time. Extra credit. The equation is 1 to the x plus 2 to the x is equal to 4 to the x. Solve for x. 5 extra point in the test number 4. Okay? So you like attach extra. So the regular question plus the extra. You get 100 plus 5. 105. Okay? Using your imagination and your common sense in this equation. Okay. Any question, guys? Clear? Okay, let's move on now to the new topic. Is a little bit complicated. It's about logarithmic equation. Logarithmic equation. Logarithmic equation. Now we studied in detail exponential. Now logarithmic. O sea, esta equation que somehow involve logaritmo, ¿no? Suppose logaritmo, example 1. Example 1. Logaritmo base 3 of x plus logaritmo base 3 of x minus 24 equal 4. Okay, this is the equation, our equation. Contain two logarithms. The variable is x. The question is solve for x, no? Solve for x. I need to find the value to satisfy this equation. Okay, what is the strategy? Always is the same. So we have 2 logarithms, 3 logarithms, 4 logarithms, I don't care. You condensing these 2 logarithms in only one, using the property number 4. Property number 5, sorry, no? 5. Remember the 5, 6, and 7. The property number 5 say que tu logaritmo, when you have plus, is multiplication. So you can then write only one time the word log, L-O-G, base 3, of the multiplication x, que es this guy, time x minus 24. And don't forget the parenthesis. This parenthesis is for notation in the LOG, no? LOG of x. I don't care if inside we have another parenthesis, but we're using different grouping symbol, a parenthesis, square bracket, whatever you equal. Everyone follow me in the property number 5? Do you understand this or no? So the property number 5 say logarithm of any base. Yes or no? Yes, okay, thank you. Sergio. Everyone follow me, no? Property number 5, yes or no? Or I need to recall? Yes, Launa dice, yeah, professor. Super. Okay, this is the crucial moment now. Okay, the most important moment now. You put an arrow here, and you convert this logarithm statement to exponential statement. And you write like that in the test. Yeah, I understand very well. You put this arrow, and you put conversion to exponential. Entonces, the conversion to exponential is, I think, first of all, what is the base in this problem? Oh, the base is 3. This is a small 3, I put it back, a big 3. Okay, the exponent is always the answer for the logarithm. So this exponent is 4. It's equal to the rest, and the rest is x over x minus 20. Okay, so at least, well, basically 3 to the 4 power is 3 times 3 times 3 times 3, 4 times is 81, no? And you can, of course, apply this 3 with the property here. Why not? You have x squared minus 24x equal 81. Because 3 to the 4 power is 81, no? Now it's a quadratic equation. Look like quadratic equation. Let me try to express it in standard form. X squared minus 24x minus 81 equal to 0. Nice. I am an expert doing that. We have no problem. We are doing by factorization or we are doing by quadratic form. In this case, it's hard to see by factorization. 81, 24, I have no idea. However, using the quadratic formula, minus b plus or minus square root b squared minus 4ac divided by 2a. In our example, a is 1 here, a1, b is negative 24, and c is negative 81. So the minus, double minus, it becomes 24 positive, minus the formula, minus the value, plus or minus, square root, negative 24 squared, minus 4 times 81 times minus 81. Divide everything by 2 times. Just 2. So I put in my calculator. 24, negative 24 squared. Actually, it's positive, no? Because when you square the negative quantity, it becomes positive. I don't put the negative in my calculator. I put in my calculator only 24 squared. Boom. 575. 576, sorry. Be careful with the sign. Negative here, double negative, become positive. This is 81 times 4. That's 324. And you add in both. Plus 576. 900. 900. Add square root 900. I suppose get 30, no? It's 30 because this is, you break it down like square root 9 times square root 100, no? This is 3, this is 10. That's 30. Good. So basically you have so far 24 plus or minus 30 divided by 2. I separate in 2 pieces, the positive piece and the negative piece. Okay. Entonces this is 54 divided by 2 is 27, no? And this is negative 6 over 2 and negative 3. Oh, by factorization was possible to discover because I need to find 2 numbers que multiply each other, give me 27. Give me 81, sorry, 81. The 27 times 3 is 81, okay, good. And somehow addition or subtraction, give me 24. 27 minus 3 is 24. Okay, by factorization was possible, but I don't see that because it's too complicated for me to see. However, in the quadratic formula, we discovered. Okay, we finish now. This is the most important moment. The most important moment is we have two solutions, 27 and 3, and you must mandatory checking that solution into the original equation. Because remember, the domain of the logarithm function is from 0 to infinity. Okay? The range number of the domain is from 0. So in other words, logarithm doesn't the negative number. So when you try to check it, suppose, let me check it. I have no idea. Checking. 427. Okay. No problem. No problem. So I copy the original equation. The logarithm base 3 of 27 plus logarithm base 3 of 27 minus 24 should be 4. I am forcing this. Si this statement is true, 27 is solution. Si this is false, 27 no solution. Okay, let me try. Using my common sense or the calculator is possible to find. How you compute logarithm base 3 of 27? Okay, remember, we are doing in different way. We are using intuition and the piece of paper, or calculator. Remember, in the calculator, we have no logarithm base 3, but we can change the base. Let's do it in both ways. Why not? Suppose, when I forgot the calculator, I have no calculator, I am in the jungle, I need to compute the logarithm base 3, I have no idea. Entonces, I copy in the piece of paper logarithm base 3 of 27 is equal, I don't know, I put x, this x is another x. Well, I change the variable, maybe it's no x, it's y. Y. So you convert this logarithm statement to exponential, the base is 3, the exponent y, is equal to 27. Oh, so no logarithm anymore, now exponential statement. And this is 3 to the third power. It's obvious that y is 3. So this value is 3, big 3. Another possibility is I use my calculator. In my calculator, I type in ln or log, whatever you want, of 27 divided by log of 3. When you put in the calculator, the answer is definitely is 3. Plus 27 minus 24 is logarithm base 3 of 3. Oh, what happens when this is the same number, the base and the number? It's the property number 2 that we study. When it's 3, 3, or 5, 5, or 10, 10, or whatever, 8, 8. The is Oswald. Okay. It's a student sent me the test. Okay, logarithm base 3 of 3 is 1, no? Do you remember the 1? Or no? Or you don't remember? And 3 plus 1 is 4. Oh, I proved that. It's true. Now the solution 27 is perfect. However, the solution negative 3 doesn't work. It's obvious, no? Because when I try to plug it in, wow, it's impossible. It's undefined. Because logarithm of the negative number do not exist. It's undefined. When you copy logarithm base 3 of negative 3, automatically I know this is, I don't copy the rest. This is undefined. Undefined. No solution. This solution doesn't work. Not always happen that the negative solution is wrong. In some specific problem, yes, it's good. Well, it's good. Suppose another example is logarithm base 3, and we have x or 20 minus x. And you plug in negative 3, entonces 20 minus negative 3 is negative become positive, es logaritmo 23. Entonces in this case, yes. So no es a rule that when it's negative solution doesn't work. No. You have to verification. How you verification? Easy. You plug in this value into the original equation. So you see inside the one logarithm we have negative quantity, obviously no, doesn't work. It's undefined. Therefore, what is my final answer in this problem, guys? My final answer in this problem is we have only one solution. The solution for this logarithm equation is solution set is 27. End the story. That's it. No more solution. Any question? Please, go ahead. Question. Okay, entonces, si hay suma, we have several logarithms. You condense in only one. Always. After that, we convert from logarithm statement to exponential statement. And when you are doing that step, suddenly happen that we have one equation que is no exponential, no logarithmic, maybe it's quadratic. In this case, it was quadratic, but in another example, it's not necessarily quadratic, linear. Okay? Depends on the problem. Depends on the problem. Let's move on to example 2. Example 2 of equation. No problem, guys. Do you follow me? Everyone understand? Or you are on holiday right now? Huh? Yes or no? Number 2. Number 2 is logarithm base 2 of 3x minus 2 minus logarithm base 2 of x minus 5 equal 4. It's a coincidence que es 4 in the right hand side. Again. Okay, we apply exactly the same procedure. You condensing this logarithm and this logarithm, but it's minus, it's subtraction. So you apply the property number 6. And the property number 6 say logarithm base 2 of the division 3x minus 2 x minus 5 equal 4. Okay, this was a little bit different to the other problem. The other problem was plus, this was multiplication. In this case, minus division. And now you convert to exponential. A statement. The base is 2, big 2. The exponent is 4, small 4, is equal to 3x minus 2 over x minus 5. Okay, 2 to the 4 power is 16. So in this moment we have, I suppose, linear equation. Because you apply now cross multiplication, you apply 16 times. Look, you convert like that. 16 times x minus 5 is equal to 3x minus 2 times 1. The 1 is invisible. And you apply this 3 with the property here. 16x minus 80, is equal to 3x minus 2. Okay, you solve for x. Because I propose you, for example, 16 stay here. Minus 3x is equal 80 positive minus 2. This is 13. And this is 78. You divide by 13 both sides. X is equal 6. And this is the final answer. No, I need to check it. I need to check. Always in the logarithm equation, I need to see solutions and check it. Verification that this solution is good. It's easy. It's just plugging in 6 in the original equation. So the original equation is log base 2 of 6. Plugging in 6 here. Replace x for 6. Replace here x for 6. So 3 times 6, 18. 18 minus 2, 16. Minus logarithm base 2 of 6 minus 5 and 1. Should be 4. I need to prove that this statement is true or false. What do you think? True or false? This is the moment, and you need to compute the logarithm, but I suppose that you know that. I explained the last class how we compute the logarithm by hand or calculator. What is the logarithm base 2 of 16? What is the value for that part? What is the exponent? Can it necessary to raise the base 2 in order to get 16? No, actually, I did F4. It's obviously 4. This guy is 4. Minus something. What is the logarithm of 1? Good. Good. 4. And what is the logarithm of 1? of 1? 0. Very well. 0 es un universal. Logarithm of 1 is 0. And for minus 0, of course, 0. This statement, of course, is true. And the solution 6 is perfect. Any question? Okay. Let's do 1, 2 more. 2 more. 2 more. 2 more. 2 more. And that's it. The logarithmic equation. The rest you see in the applications. Suppose number 3 equation, number 3 example. Example 3 now. It's logarithm base 14. So I don't know why some problem of the logarithm equation contain non-standard base 14, 2, 3, 5. Okay, you have no problem with this. You know the famous formula that allows us conversion of non-standard base to standard, no? The chain of base 4. Okay, the new thing that brings me this example is that the logarithm and the equation is located in different side, but I don't care. I move this logarithm to the left, and that's it. Logarithm base 14 of x plus 5 plus logarithm base 14 of x equal. And now ready to condense in this and this in only one logarithm, base 14. And you apply property number 5 because of plus. And it's a multiplication, x times x plus 5. Equal 1. Now conversion to exponential. Now when you conversion to exponential, the base is 14. Look here, the exponent is 1. And by the way, 1 is invisible. I don't care. It's equal x plus 5. Okay, and you why not apply distributive property? 14 is equal x squared plus 5x. At this moment, we have quadratic equation one more time. I'm putting a standard form, move 14 to the one side. Now factorization maybe is easy because I suppose that 7 and 2 work perfectly. Because 7 and 2, 7 times 2 is 14, and 7 minus 2 is 5. The sign is positive 7 and negative. So actually, we separate into solution. Okay. X is negative 7. And x minus 2 equal to 0. Is positive. Negative 7 to be a good candidate to be no solution. Because a negative number. Actually, yes. Because when you try to plug it in, look in the original. Or in either way, here. Plugging in here or plugging in here. Logarithm of negative number, not good, undefined. And let me try to prove true. 2, sorry. Logarithm base 14 of the 2 plus 5, que is 7. I substitution 2 here, replace 2 here, and 2 here. Should be equal, I need to prove this. 1 minus logarithm of base 14 of 2. Well, we are doing similar to the idea. I move this logarithm to the other side. Plus now. Equal 1. And why no? You condense it. I don't like 2, 3, 4 logarithm. No. Only one logarithm. And remember, you apply the property number 5 again. And the property number 5 say get the multiplication. Get 7 times 2 is 14. Wow, look at that. And we have the classical idea when the base and the number inside the argument is the same as 1. Okay. Let answer 2 is perfect. Any question?
You did 7 times 2 to get 14, Professor?
Say again.
7 times 2 to get the 14?
I don't understand. What is your point? What is your question?
How did
17.
you how did
Uh-huh. Okay, listen. You asked me about that part, I suppose?
yes,
Exactly.
yes.
Okay, you have two logarithms with the same base que 14. Yeah, I know the property number 5 can say that when you have two logarithms, we can condense it in only one. When it's plus, you multiply this number and this number. 7 times 2 is 14. So you condense two logarithms in only one. And by coincidence, this number is exactly the same of this. Yeah, I know the property number 2. The property number 2 says the logarithm a of a is always 1. When the number inside the argument is equal to the base, the answer is 1. Clear? Clear or confusing?
Clear, clear.
Clear. Okay, super. Well. Let me try another. Let me try, but not too complicated. Okay, look, the last one. And the review packet, we have another more complicated. Example 4. Suppose log 3 plus x minus log x minus 3 equal log of 3. Wow, in this case we have 3 logarithms. Very good. Here we can condensing everything you put in the same side. Oh, another possibility is condensing this and this. Using the property number 6, que the property number 6 say when it's minus division. Entonces you condense the logarithm of 3 plus x divided by x minus 3. By the way, I forgot something. I do know a specification the base here. Why not? What is the interpretation of this? Because when there's no specification the base, you suppose default, que es 10. Ok. Ese como logaritmo este. Super. But in this case, look, most easy this example. Because in the left-hand side, we have one logarithm, and the right-hand side, we have another logarithm. And I know very well that logarithm and exponential, both are one-to-one function. Therefore, if this logarithm is the same and the base is the same because it's 10, then the expression inside is the same. Okay, remember, it's like the students delete this, but I don't like to delete. This is no lies. It's no theoretical good. But you in your mind, you could delete. So you apply cross multiplication, and that's it. You convert to a linear equation. 3 plus x is equal to 3 times x minus 3. Apply this 3 with the property, 3x minus 9. Solve for x. I propose you now. What's going on? I understand. Okay, look. Suppose 3 stay plus 9. I move to the right, to the left. 3x stay minus x. Is 6. You're right. Super. So this is 12. This is 2x divided by 2. Is 6. Super. I need to check it, no? Or no? No checking. Or we have to check it. Okay, checking for 6. Plugging in 6 in the original equation. The original equation is log of 9. No? Where come from 9? 6 plus 3. Substitution here, 6 and 6. Minus. Logarithm base 6 minus 3 is 3. Should be equal to 3. Should be equal logarithm 3. So. Wow, it's super easy to prove that this statement is true, no? There are many ways to prove that. How do you prove that? Well, exactly the same. Property 6 maybe is division. So you condensing this in only one, que is 9 divided by 3. This 9 is this 3 is this. Should be logarithm 3. 9 divided by 3 is 3. Logarithm 3 is equal to logarithm 3. True statement. Therefore, this expression is okay. This solution is okay. Okay, super. Okay, let's move on to the last part. Is the application. Application, exponential equation, and application logarithmic. The first application is the finance application. So it's the money when you invest the money in bank account and no withdrawal, the money stay here, accumulate interest. Entonces es the compound interest formula. Okay, compound interest formula. Let me try to explain the formula. And let's do in several problems of the compound interest. Okay, suppose to understand the finance, well, I define something, P, capital P, it's a present value. Present value. Present value is the money that you have right now. I have in my hand $500. It's a present value. I deposit, I open account, I deposit this money in one bank account. And this bank account offer me interest rate. Interest rate. Okay, que es suppose to simplify the thing, annual percent rate. After I want to complicate with different situations. And normally the letter we use in the verb is R. R is interest rate. Read R. Okay. Let me try to understand the cash flow line. Cash flow line. Okay. This is at t equals 0. Now, I have that money. P is the present value. And the time flow, cash flow. Suppose this is t equal 1 years. I want to prove the formula for the years, but it's valid for a different period. I want to explain for year because it's easy to understand. So now, throughout this line, the money is increasing using the interest rate. It's R, so it's RP. The total money that we have in this point is P plus RP. Because it's the initial money plus interest gain. And this is P1 plus R. In the second year, T equal 2 years, well, we have again the R, but R multiplied here by this money. Okay, this money is P1 plus R plus the money that you have in the period, in the previous period, okay, P plus 1 plus R. Okay, now you factorization here, 1 plus R, P, and we have R plus 1. R plus 1 times itself is P1 plus R squared. Oh, it's no coincidence. Okay, this money increasing using the CS1 year, the power is 1, CS2 year, the power is 2, CS3 year, the power is 3, and in general CSN years, the power is P1 plus R raised to the T. T is the exponent. T is the amount of years. Well, in this case, T years. No A, T. Don't confuse the letter because the formula is N is another thing. Okay, this is the formula, no? Okay. This is, let me think. Let me define another guy important. Okay. Capital A is a future value. Future value is the money that you have in a specific time. This is my future value. in T years. Now the formula is future value is equal present value 1 plus R raised to the T power. T represents years. R is interest rate. Normally the interest rate in the problem is expressed in percentage, but whenever you plug it in here in percentage, you need to convert percentage to decimal. Suppose que 6% interest rate is 0.06, the value that you plug it in here into the formula. This is no, this is dollar and this is dollar. Okay? Let me try to refine a little bit the formula because I include another more important thing. We almost get the formula, but I need to refine something. Let me refine this formula using compounding. What is compounding? Compounding is not necessarily the partition and the cash flow is per year. Maybe it's for example per month, per quarterly. Okay, suppose this is 1 year, 0, 1. And I divide the year in 2 parts. This is 6 months, and this is 6 months. This amount of compounding is called semi-annually. Annually. Because we have n equal 2. Because you divide 1 year in 2 parts. Or suppose another possibility, you divide it by 4. It's a quarterly. 3 months, 3 months, 3 months, no? 3 months, 3 months, 3 months. Entonces, this is quarterly. Quarterly. No double L. Quarterly. Quarterly. M. The new variable that we introduce here is M. Okay, M is the compounding. The idea that I try to convey is, look, I want to introduce compounding is one letter is M, compounding. Compounding is, suppose, N equal 1. This is annual. Suppose N equal to semi-annually. Annually, U. Annually, MN, annually. Double L in this case, annually. N equal 4, quarterly. N equal 12, oh, it's monthly. 12, it's monthly. N equal 52, it's weekly. N equal 365, it's daily. So we are doing different partitions, depending on the partition, no? You apply. The formula change a little bit when you include the compounding. The formula, the useful formula, the final formula that we are using every day is future value is equal present value 1 plus. Therefore, R is the interest rate. You suppose always is annual percent rate. If you divide a year in different period, you divide the interest also by the same. Suppose que the interest in 1 year is 5%. The interest in 1 month is 0.05 divided by 12. And the amount of period is increasing. T is the years, but the amount of period is NT. So the exponent is the multiplication N and T that represent the period. Suppose in the case semi-annually, 1 year, suppose you have 1 year, but actually we have 2 periods. 1 period, 2 periods. So say 1 year equal 1 year, and N is equal 2 because it's semi-annually. Suppose que in the problem of the loan, we have 30 years. Pero I need to find the interest rate. So you divide by 12, no? Pero the amount of period is 12 because 1 year have 12 months multiplied by 30. Wow, it's 300 something, no? 360 period that you need to pay. Well, this is valid for pay or this is valid for earn money because when you deposit the money, your money increasing like that. Look, this is the time. This is the money, okay? And you have P, is the present value at T equals 0, and the money increases, but increasing like that. And increasing fast because this is the power form of the compound interest. This is amazing how the money increasing. So I recommend you, everyone, doesn't matter if you are no millionaire, you invest your money. You save money and invest in one CD account or you buy shares or something in order to increase your money. And at the beginning, no. But in one moment, your money working for you. Okay, this is super important. I have a question when you are able. Anytime. I am able anytime. San giving no. But
So,
you know how you reach me. Okay? You email me.
Okay.
You want face. We activate the Skype. Okay? Totally additional.
I just
Go
have
ahead.
a question about what this is. So the final formula that it's square, that you put a square around, that formula applies for everything in these word problems, or is this formula
No.
broken down in 3 or 4 different ways to do basics all the way?
Absolutely. You are right. Okay. But wait for me. I bring different problems to illustrate the application of this formula. Okay.
Thank you, sir.
Let me. I want to start for the elementary kindergarten example. No? So little by little I complicate. But no, it's okay. This is the okay. Let me copy. You guy. I don't check it. See, I record the video. No? Let me see. Yeah, I record. Somebody record. Yeah, you're fantastic.
This stuff is blowing my mind. I don't know why, but
Well, okay. Somebody. Thank you. I appreciate it so much. Okay, let me see. Let me copy the formula, guy. Erase the board. I can. May I? Okay, look. Okay, one possibility of the express the compound interest formula is compound interest formula. Bueno, es future value es equal present value, parenthesis, 1 plus R interest rate, M, and T. Okay, this is the classical formula. This is the classical formula when you have, for example, one specific money and you need to reach this money. I want to buy a new car, but I have only $10,000 and I want to buy BMW and BMW is, I don't know, $57,000 to say how many years I need to waiting for this. Okay, this is the classic. Another formula gets derived for this. Es suppose que I am doing backward. I want to find how much money I have now in order to reach a specific future value. Entonces it's easy because the only thing you should do is isolate P, the present value, as a function of the future value is division. No? 1 plus R over N raised to the N. Okay, entonces I call this formula is future value formula. And this formula is present value when you need to find present value. Depending on the problem. Okay. Okay. One specific, interesting, and you need to know for the test is when the special case. This is special. Special case when n approaches to infinity. This call it continuous. Continuous compounding. This is theoretical, of course. Compounding. Pero you apply in some problem that you have no idea what is the rule. For example, in finance, to predict the price of the stock market, okay, you using this idea. You suppose que es no discrete. That you suppose que the stairs of the money is not like that. Suppose que es continuo. Entonces, continuo es when the n is infinity. O sea, the partition here is no 12, no 365. Es anytime the money increases. Entonces, the formula change a little bit. Future value is equal P, same P, pero exponential, E to the RT. This is the formula for the continuous. Continuous compound. Entonces, the money increasing exponential. And the present value is the future, continuous. Continuous compounding. And present value is the same, but the exponential is negative, minus R. Okay? Okay, let's move on directly to the problem because you are exciting to see something application. No? Okay. Let me go here. Let's move on to that. Suppose the example one of the finance problem. Suppose if you have in your hand $10,000, is you make a decision invested in one bank account. And this account offers 3%. This is the interest rate, APR, annual percent rate. Always is expressed in annual, the interest rate. This is like a standard convention. No? However, the account is compound quarterly. Entonces, the question is how much will be in the account in 5 years. So the supposition is if no money is withdrawn. Okay. It's obvious, according to the information that we have in the problem, this is the present value. Present value is, I like to write the data. This is my data information. I read the problem, but I need to understand. Interest rate are 3%, but never is present percent, it's present in decimal, divided by 100, 0.3 over 100. In decimal, 0.03. You put in the calculator. One more information we have. This is the interest rate. 3% is present decimal. Compounding quarterly. That means N is 4. N is 4. And the T is 5. And the T is 5. 5 years. And those, what I need to find? I need to find future value. Future value is our unknown. I don't know future value. And this is not continuous, it's discrete, because we talk about quarterly. So my stairs contain 4 steps. Actually, it's not 4, it's 20. Because NT. So we have 5 years, but you divide each year in 4 quarterly. Actually, my stairs contain 20 steps. But I don't care that part. I care, for example, the formula. Because the formula is future value is equal present value, 1 plus R over N, NT. It's the famous compound interest formula when it's discrete. When it's continuous, no, it's exponential. Oh, okay. Entonces, and my problem is P, que es 10,000. 1 plus R is 0.03 divided by 4, no? It's a compounding divided by 4 raised to the 20 power. Where come from this 20? It's the multiplication 4 times 5, 20. NT. N is 4. T is 5 years. Multiplication 20. And put in the calculator. Be careful. It's important that you try, guys, to put in your own calculator. So how you put in the calculator? You put in the calculator 10,000 first. Multiplication. Open the parentheses. I suppose that your calculator has parentheses. 1 plus 0.03 divided by 4 raised to the 20 power. And press enter. Tell me, what's the answer of that? Tell me. Do you have calculator or no? Remember, I told you any class from now calculator because we need to compute a specific. How you put power in one key, dependency is TI30 calculator, TX30 calculator. Eso, bueno. The answer is 11,000. Let me put a comma, separate the 1,000. 611. And you truncate the decimal place to decimal place because it's cent. Because remember, this is currency. This is money, a currency. Okay? Super. Super good. Any question? The money increasing not too fast because the penny is 3% only. 3% is not too much. You need to open maybe CD account that offer at least 5% to see your money increase a little bit. Okay, that's example 1. I have another example, example 2. Example 2 is more interesting. Okay, let me erase the board. Everyone get this answer? $11,611.84. Everyone, yes or no? Yes. Okay. You have another problem now. And this problem is a little bit different because, example 2. Because you have present value is $2,300. You have interest rate is 6.5%. Automatically, I don't care. I convert to decimal, 0.065. Okay? And this is annually. Nice, because the compounding is annually. The compounding is 1, because it's 1 years. If you don't divide the year and the month into the 80, nothing. It's year per year. 0 year, 1 year, 2 year, 3 year, 4 year. Yeah, I need to reach future value at least $4,000. Yeah, I need to compute how many years. I have no idea how many years we need to reach $4,000. Okay, no problem. I'm using the same formula. Let's solve a discrete problem. In this case, we have compounding 1 is easier. You copy the formula. Okay, it's P parenthesis 1 plus R over M raised to N. Okay, I plug in substitution. Who is A? 4,000. Who is B? 2,300. Parenthesis 1 plus 0.065 divided by 1 because compounding is 1 because it's annually. And 1, you know, it's invisible. Divided by 1 is invisible. N T. N is 1, T is the thing that I don't know. I need to find T. But in this moment, we have exponential equation. Of course, exponential equation of the ugly exponential, because you never can express this ugly number using the same base. No, it's impossible. Okay, but we are doing something. You divide, for example, you divide both sides. Well, actually, I do several things. You divide both sides, 4,000 divided by 2,300. It's obvious that we cancel out these 2 zeros. Inside the parentheses, we have 1.065. Because 1 plus the decimal is this, no? So actually 40 divided by 23 is 3. Is equal 1.065 t. No. So we have a relatively easy exponential equation. Of course, it's the equation that you need to apply logarithm on both sides. Logarithm of this and logarithm of this. Entonces yo apply one more time the property 7. The property 7 allow me put the time like a factor here. Entonces we have logarithm of 40 divided by 23 is equal to logarithm of 1.065. Finally, divide both sides by logarithm of 1.65 because I want to solve for t. Logarithm of 40 over 23 inside the parenthesis divided by ln. I'm using ln, I don't know why. You can use ln or log, either way. 1.060. This is the time. I put in my calculator. How you put in the calculator? When you put in the calculator like that, be careful. You put in the calculator like that. ln or log, either way. In this case, I'm using ln. Entonces, open parenthesis. 40 divided by 23. And close the parenthesis because ending this logarithm. Division now. Division. ln again, 1.065. Press enter. Enter. And help me what is the answer. Help me what is the answer. Help me, please. $8.79. 8.79. 79. Good. 79. Entonces now they want to know, and the problem normally say, wait. I don't want decimal years. This have no sense. Entonces the problem is que you reach $4,000 in the middle of the 8 year and the middle of the I suppose que es in the middle it's 9 years, no? It's 9 years. You round, but round up. Will be 9 because have no sense to say. So in 8 years, for sure, we have less money. In 9 years, you a little bit overcome. In the year number 9, in the year number 8, no. And the year number you reach exactly in this decimal. Pero entonces, actually, the answer that they want is no decimal of years, you round. But you round up in this case. Round up. Okay? If you want verification that this idea is good, let me try to illustrate and the rest of the time it's not too much. Okay, let me try to open Excel spreadsheet. Entonces, in my opinion, this is fantastic to understand the compound interest. I open new spreadsheet Excel. Let me share the screen. Can you see the thing I want to do? Look. Spreadsheet Excel. Microsoft Excel. Okay? Entonces, I want to investigate this problem in Microsoft Excel. I put here years. Do you see or no? Do you see Microsoft Excel? Anyone saw Microsoft Excel? Yes or no? Yes, Microsoft Excel. And here is the money. money, 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 no, money. Okay. And we start in 0, year 0 is now, and after 1, and after 2, well, no, you select this, and you drag. I don't know exactly how many years. Entonces, en T equals 0, we have 2,300, no, dollar. Okay, let me format in dollar, because Excel allow me a dollar. Okay, nice. And in one corner here, I write interest. 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 Interest rate. So the famous R. No? The famous R in our problem was 0.065. Always in decimal, guys. Always in decimal. Okay. Now let me try to compute the money that we have in the year number 1. Well, you open the equal sign, este calculator in the different cell of the Excel. You click here, get the present value, your multiplication, open parentheses, and you put 1 plus R. This is R, the interest rate. But be careful, because I need to put double dollar to indicate que es the absolute reference. I don't know if you remember this of the computer sign, but this is important, because when I copy paste that formula, always this pointing to the same value, okay, the interest rate. Okay, so you don't put this, when I copy and paste here, we have different situation, no? Oh, look at that, what happened here. In 9 years, we have 4,053 and 91 cents. In 8 years, it's 3,800 something. So you see the confirmation clear. Don't try to compute it by hand, because it's crazy. Suppose we are doing the computation for the 30 years. No, it's crazy. No, I'm compounding daily. Entonces es too long. Entonces we using always a spreadsheet Excel to verification, because we are, of course, using the famous formula. And we get the answer. Any question? Any question? Do you understand very well this problem? Complicated or easy?
It's easy. Could we take like do this in Excel and take a screenshot and send it to you, or no? You don't.
No. In the exam, you are doing by the formula. That's it.
Understand? Okay.
No, the formula. This is just in case if you want to verification. Well, okay. Suppose another similar problem. Suppose similar. The last one. I promise it's the last one, because you want to go directly to holiday, no? Example 3. Example 3 is similar. Suppose que one guy, John, want to buy a car, and the price of the car is 30,000. This is hypothetical. It's the price of car.
Professor, you're still on the
Sorry. Coño, I forgot always. Thank you.
Professor, I'm sorry, I can't see the board. I just see the Excel.
I know. Flora told me. Pero let me. Switch. White bar. Okay. Do you see now? Do you see now?
Yes.
Okay, super. Suppose another word problem similar to the previous. John want to buy a car, and the price of the car is $30,000. And he 27. This is the money saved. In your pocket, your account, I don't know. Entonces we need to find again the number of years. Year, remember, is T, in which she need to deposit this money, and this money to grow to this money at one account. It have 4% annual percent rate. Compounding quarterly. Compounding quarterly. Okay. Let me translate this to the mathematical language. I suppose that this is the future value, no? This is the money you want to reach in the future. This is the present value of the money I have now. Or no, me, John. This is the time. Again, it's the unknown. I don't know. This is interest rate, but it never expressed like that. Expressed like a 0.04. And compounding mean n equal 4. Because 1 year in this account, he deposit in his bank, suppose the year that the money increasing like that. Pam, 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 pam. Okay? This is 0, this is 1 year, this is 1 quarter, 2 quarters, 1 half, 3 quarters, and 4 quarters. Okay, so my formula again is this formula. This is 30,000. This is 27,000. 1 plus 0.04 divided by 4, because n is 4, and the interest is the coincidence is 4, and raised to the nt, but n is 40. Okay, and this is my formula. Okay, we cancel out this 0 and this 0, no? Entonces 30 divided by 27. And by the way, you divide by 3 is 10 over 9. It's equal, 0.04 divided by 4 is 0.01. So we have 1.01, because 0.04 divided by 4 is 0.01, plus 1 is 1.01, raised to the 40. So in this moment, we have exponential equation, okay, and you solve the exponential equation. How you solve the exponential equation? Apply logarithm. What kind of logarithm? Either way, a standard, of course, because my final answer is using the calculator. For example, I put log, the common logarithm. Apply the property number 7. I know that 40 come to the front as a factor. And finally, solve for t. Divide both sides by 4 logarithm. The answer is log 10 over 9 divided by 4 times this multiplication, log 1.04 in years. How you put this in your calculator? Be careful.
0.04 or 1.01?
0.1. 0.1. You're right. 0.1. 0.1. Here. A1. A1. Thank you. How you put in the calculator? You put in the calculator like that. log parenthesis 10 division 9. Close the parenthesis. I finish the top part. Division. Open the parenthesis. In bold. Enclose everything in the bottom. It's important for multiplication time log parenthesis 1.01 close double parenthesis. Parenthesis of the logarithm and parenthesis artificially I put here to enclose everything. Press enter and let me know what is the answer. How many years John need to wait to obtain the money for his car? Please help me. How many years? 5 years, no? No. Let me check in my calculator, guys. 5 years, no. 5 years, no. Okay, look. It's log. A ver, another answer. Oh, yes, 2.65. 2.65. The answer is 2.65. But actually, we don't express the time in year, 3 years. Idiots. Very well. You want to make sure? Please,
I have one question.
Go ahead.
How did you get 10/9? Like, did you convert it?
No, was it you reduce the lowest term risk? 30/27. You divide it by 3 is 10, divided by 3 is 9. 30 divided by 3, 10. 27 divided by 3, 9. Super. It's okay? It's okay, miss?
Yes, got it, Professor.
Okay. Well, I wish happy holiday for everyone. And enjoy and don't study mathematics. Well, no, si you are late in the homework online, you have to work a little bit. Okay, thank you for your attention. Okay, thank you, sir. Okay, take care.
Thank you, Professor.
No, pleasure.
Happy Thanksgiving.
Happy Thanksgiving, everyone.
Thank you.
Okay.
Happy Thanksgiving.